Okay, so you'll be able to find all these answers on my notes when I post them to my website also. And let's move on. Okay, this one has 2, and there they are. This one has none. Number 20 you didn't have to do, but it does have 4. 21, the circles just need to be touching in one spot. Touching at one point. That's tangent. Somebody asked about 23. How could you just get one common tangent? You'd have to put one circle inside the other for that one. Okay, any questions on 18, 19, or 21? All right, let's keep moving then. 24 is yes, because AB is perpendicular to BC. 25 is yes, because the converse of the Pythagorean theorem tells us. We see that 3 squared plus 4 squared does equal 5 squared, so we know they're perpendicular because that's a right triangle. And this is no, because A squared plus B squared does not equal C squared. Do you be any questions?
No.
Okay. I did not ask you to do 27 and 29, but we did one like this in class. So let's do 27 together, and then I'm going to give you 29 to try. So, it says find the radius if AB is tangent to circle C. So what we would do is say leg squared plus leg squared is equal to hypotenuse squared. And we talked about on Friday how you would square a binomial. R plus 2 squared is really R plus 2 times R plus 2. And so we're just going to distribute through here one term at a time. R times R times 2. R times R is R squared. R times 2 is 2R. And then distribute the 2. 2R and 4. So this gives us R squared plus 4R plus 4. What happens to the R squareds? They cancel. So we get 16 equals 4R plus 4, so 12 equals 4R, so R equals 3. You try number 29.
Oh, 29?
Yes.
Dang it. I didn't know we were doing this. Alright. So.
Okay, let's put that away, or it can be mine for the rest of the class period.
I'm about to look that up.
Even though I should know that, but it's 2.5.
Hey!
What'd you get?
8. 8. Is that wrong? That's right. That's got
8-hour test period. Get all the books.
8 is correct. So we get R squared plus 15 squared equals R plus 9 squared. So we get R squared plus 225 is equal to, when you multiply that out, you should have gotten R squared plus 18R plus 81. So the R squares cancel and we get 144 equals 18R. So R equals 8. And so that gives us 8, 15, 17, which is one of our Pythagorean triples. All right, how did you do? Okay. All right, here we have tangents from this common external point. So the two tangents must be congruent. So you set them equal to each other and solve. Any questions on 30 through 32? take a look at these. These are pretty self-explanatory.
Semicircle choice.
Okay. All right. So on numbers 12 through 21, the first thing you had to do was find the missing angles. So since 70 and these two are vertical angles, this one's also 70. These two are vertical. Now this little angle right here is 30, and then 30 and 70 make 100. So since the three of these make a straight line, that would leave 80 for this one. If this one's 70, these are a linear pair, so that leaves 110 there. And then once you know the information about the central angles, the intercepted arc is equivalent to the central angle, and so you ought to be able to get them. Any questions about these?
God bless.
Okay. Now, to have congruent arcs, we have to have two things. We have to show congruent radii and congruent central angles. So 29 is yes, because the central angles are congruent. We have the same circle, so obviously we have the same radii. 30 is yes, because we have congruent angles and congruent central and congruent radii. And then 31 is no. Though it does show the same central angle, it does not show congruent radii, so we cannot say that they are congruent arcs. Any questions? All right. Okay, go ahead and check these. I have an issue with the way number 38 is worded. If it was talking about a major arc, it should say from 7 to 3 instead of from 3 to 7. Do you see what I'm saying?
But it's the corresponding, so wouldn't that be like the other one?
No.
That's how I thought it.
Well, yeah.
That's what I thought.
I think that's what they were doing, but they used a math word incorrectly, if that's what they meant.
That's what I thought it meant.
Yeah. So, if you did from 3 to 7, that's 120. But from 7 to 3 is the 240. Alright, on this one, it says halfway between the 1 and the 2. Well, there's 30 degrees between each of the numbers. So halfway would be 15. And then 4/5 of the way would be 4/5 of 30, which is 24. And the difference in those two, 24 minus 15, is where we get the 9 from. Were you guys good?
Are you recording this, Mr. Ruby?
Yes, I am.
Good, Michael.
Oh, Michael. Y'all are assuming they'll watch it.
I'll make sure he watches.
All right. Let's take a look at today's lesson. Today's lesson is all about chords.
Yes.
All right. The first thing it says, in the same circle, or if we have congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. Now that if and only if tells me I could switch the order of this. And we could say corresponding chords are congruent if and only if their minor arcs are congruent. It goes both ways. So if AB is congruent to CD, then arc AB is congruent to arc CD. Vice versa. Make sense? Okay, so they tell us we have two congruent circles, and we can tell that because they're circles that have congruent radii. That means the circles are congruent. And then it also states that BC is congruent to EF. So the measure of EF is 125. What would the measure of BC have to be? The same, 125. And the reason they're the same is because those two are congruent chords in congruent circles. And the corresponding minor arcs would have to also be congruent. Okay, if one chord is a perpendicular bisector of another chord, then the first chord is the diameter. So if they show us that this chord is a perpendicular bisector, then we know that SQ has to be the diameter. Now this is similar but a little bit different.
Miss Wilby,
Yeah.
so that only applies for SQ, it couldn't apply for TR?
Right. Because TR is not bisecting SQ,
Okay.
but SQ is bisecting TR.
Okay.
But if SQ was just like lowered down a little bit, it wouldn't be the diameter, but it would still be
But
bisecting.
because
Correct. It'd just be two chords and it wouldn't be bisecting either.
It wouldn't be bisecting, it would just be.
Right.
It
So
would
then
just be a
it wouldn't be,
perpendicular
it has to
line.
be going
It would just-
perpendicular
correct.
and it has to also be bisected.
Correct.
Yeah.
Perpendicular bisectors. Got to be both. Got to be both. Okay. If a diameter of a circle is perpendicular, so we're starting out with a diameter and we know it's perpendicular, then it's going to bisect the chord.
Oh, yeah.
So if we know it is the diameter and it is perpendicular, then it also bisects. So that DH is congruent to HF. Those two segments are congruent. Oh, wait. They did say, they already wrote that. This is where the arcs and the arcs are also congruent. Sorry. DG and FG. It doesn't matter. Okay, so let's skip to these checkpoint problems. Tells us, just looking at the picture, what do we see?
RS is congruent to TV.
Good. So we have two congruent chords. So what do we know about their arcs? Their intersecting arcs are also congruent. So if the measure of arc TV is 121, then the measure of arc RS would also have to be 121 degrees. Make sense? Now, on this one, we have a diameter that is perpendicular to a chord. What's it going to do to the chord? Bisect it. And it also is going to make congruent arcs. So we know that 4x would have to equal 80 minus x. So 5x would have to equal 80. So x is 16. And now it asks us to find the measures of these. So the measure of arc CB, 4 times 16, 64 degrees. And the measure of arc BE, well, we know those arcs have to be congruent. And 80 minus 16 is also 64 degrees. And then if we add up, we can just double those two congruent arcs to get the bigger one, which is 128. Make sense?
It does. This is our whole way from last year quarter. See what can teacher. We had a teacher. She just sat on her desk. Oh.
Okay. Now, if we have the same circle or two congruent circles, and we have two chords, they're going to be congruent if and only if they are equidistant from the center. So AB is congruent to CD if and only if, good, FE is congruent to EG or GE, doesn't matter. So this is going to be congruent to that if and only if that is congruent to that.
So on this test, what of the two little lines already put in?
Yeah, or it'll have words that say it. It'll either have words or the mark. Okay, like this one, I don't have to mark it because you can see that AB is congruent to CD because they're both labeled 12. So since those are congruent, this must also be congruent to that, the distance from the chord to the center. So we can say that 3x equals 7x minus 8. So negative 4x equals negative 8. And x equals 2.
Oh, I guess 12. Guess what's
Okay. So we knew that it was equidistant because they were congruent chords. So EF would have to equal FG. And so EF would have a length of 6. Okay, so let's take the same picture up here, but this time they're telling us that AB is 27. And EF is equal to FG, or GF, which is 7. So this is equal to that. So what do we know that AB and DC are? Congruent. Good. 27. If the distance between the center and a chord is equivalent to the distance between another center and a chord, then those chords are congruent. It's worded weird, I know.
but the question is just kind of so
Obvious. Yeah. Okay, guys. Your homework is pages 211 through 213, number 24. Now, because you have enough class time to finish this assignment, anyone that is present today that has an incomplete assignment tomorrow will get a 0 and detention for not using your class time wisely.
Oh, God.
Okay? So let's work.
so absent